Hello YouTube viewers, welcome to my channel Science to Technology. In today's video, we're gonna discuss and actually build a industrial socket. So basically this puppy. Now be mindful, every nation has their own ecosystem. However, when it comes to industrial, there's surprisingly few options. And even though we are talking about India's point of view, this plug may be very familiar to people who are in Europe. They're like, dude, this looks like normal European plug. Yeah, that's the whole point. The design of European plug is surprisingly good. Meaning, if you take this plug, it does have one flaw, but other than that, it's actually very good. Is that you plug it in, but you can see even before we have made any insertion, it's completely surrounded by plastic. Meaning, I should not be able to touch any live conductor. Now you plonk it in, it still does not go. Like it's still not connected. You have to plonk a lot so that that ensures that under no circumstances you should be able to touch any live conductor. It should be safe. Now these are not very expensive. They are used a lot in audio industry, industrial electric charger, all that. And because these are a bit different compared to your normal plugs, so to say, so you cannot just have people just coming like this and it's like it won't fit. And this is a 16 amp plug. This used to be the older British design. This is India's current standard design, and British only thing they have changed in their current variant is instead of these cylindrical things, they have flat fingers, you would say. You can see these are big plugs. Compare that to normal Indian plugs that are smaller size, so to say this size. These are 6 amps, these are 16 amps. However, these plugs are rated for 16 amps. So why I'm looking into this again, unfortunately for some reason, a lot of Indian tools and a lot of Indian products use this plug for some reason. Even though if they need earthing, is like you can connect this to normal socket. Let that be very clear. Like if I have a normal socket, I can just plug this puppy in. It will work. Problem is earthing is not connected. So that's sub-ideal, and my oscilloscope has this sort of socket. It's quite common for charging bricks to basically come with this sort of puppy. So I do need a socket. Now this is a very this socket I just built for my Hindi channel, so I'm gonna make a bigger one. This is a, as you can see, 6 amp one. I'm gonna try to build a 16 amp one for basically heavier loads if I need it. I bought 2 units because again in a pack set it was cheaper. So I got 2 plugs. I have no use as of now, but I have 2 of these puppies, so let's use them. So I'm gonna use basically 1.5 millimeter cable. So let's take 3 of these puppies. So in India, color code is still logical. I have no idea who the heck was smoking weed, and they literally changed logical colors like, you know, red, black, green, blue, yellow. Simple colors, primary colors, super easy to distinguish, to grays and weird colors. It's like, why? So let's take a quite a long distance one. Should I? Well, cable should hold up. And do not worry, I do have basically heat shrink, so I'm gonna shrink this puppy reliably. Yeah, I think this should be, yeah, should be sufficient. Let's cut these puppies. And okay, so we got the cable. Now let's put some heat shrink because otherwise it will become a mess. I'm gonna use some pro grade heat shrink, basically 3-to-1 heat shrinks. So let's see. Come on. Yes. So 3-to-1 heat shrink, so it will shrink much more tightly, and it also has glue, so it's robust. These things are robust, or at least I hope so. They cost a lot, so that's the aim. So now, why the heck we want an industrial plug different from normal plug? Well, normal plugs are designed for convenience and low cost, while industrial plugs are designed for basically they have a bit more freedom on the construction side to be a bit more expensive, bit more robust, because they are supposed to be handled by people who are dealing in rough environments. And there are only 2 things that are very destructive to things: A, children, who are destructive to everything, and B, worker environment. So any workshops and things of that nature, you will buy products that are like industrial, tough, heavy graded, all that jazz. It means nothing. If you put in a workshop, you'll be lucky if it lasts even his expected lifespan. Like those environments are very rough. So that's why we have a different ecosystem. And again, if you really want to connect like 3-phase equipments, normal plugs are not designed for that. USA is a bit weird in this regard. They have a 2-phase multi-phase connection for normal application. but USA is weird like that, because it's like, dude, just use 3-phase. Why using split phase? So I think this should be sufficient. I'm using red one because my black one is very low. I've used black one on other projects. Yeah, so that's how we got it. Okay, ta-da. Okay, now let's take care of the plug side. So this plug is a bit old. I did not add any fresh one, but this is old school puppy, so they are made very robustly, meaning the nuts, basically screws and nuts, they are not directly going into plastic, they are going into threaded metal insert. So as you can see, like threaded metal insert, so it's a bit more robust. It does have I think this is sold. I have lost the cable grommets, that clamps that was there in order to hold it, but it is what it is. Let's move forward with it. You can slice all 3 wires in the same go, but generally you're supposed to slice green wire bit longer than the red and black bit. So okay, so now we slice it, but as you can see, this is a stranded wire. Stranded wire are notorious for plugging into things, so you're supposed to use ferrules. Now these ferrules will make our life much easier and much more reliable. Ta-da! Then you're supposed to take a ferrule crimp and ta-da! Now I can screw in and screw out. It will not damage the basically fragile conductors. And be mindful, you may be like, can't we do the same thing if we solder it? Yeah, no. If you solder it, anything that's supposed to have flexible movement like a plug, it will crack from there. Again, it will not happen on day one, but it is the reason why we have even ferrules in the first place. And that's why, like in vehicles, you can pay attention to the fact that they use basically very fancy systems rather than utilizing on soldering. Solderings are very, very fragile. If you are not moving, it's awesome, but like if you have motion, then it's really not ideal. Let's just put it that way. It's not ideal. Let's put it there. And color code of the ferrules are completely different than the color code of basically wires. So sometimes if you really want to be professional, because why the heck you need to be that much? Insurance. If you want to make sure that your insurance agent does not just like magic, oh, you did not do this or you did not do that, you want to be extra secure. So in those sort of scenario, people have bought like a bigger version of this, and you do notice that in high voltage requirement and high load scenario, you have to use this sort of thing where you have heat shrink on high voltage, and those heat shrinks are color coded properly, ideally. So now I'm tightening it down, so it's far more reliable. I do not have to worry about cable spraying out. That's the whole point of ferrules. Far more robust and reliable. Now we go into red. The faceplate has the number N is for neutral, neutral is black. Again, why the heck America has such a weird color code? Like Europe, I get it. Europe sometimes smokes too much, but like why the heck America has a weird color code? Like that does not make sense to me. Why? Why the heck you guys do not have simple, oops, I stabbed myself. Happens. Life. Okay, now the red wire. Okay. We have to tighten it because we are talking about a lot of amps possibly be drawn from these puppies. So we have to be damn sure they're as tight as needs to be. Yep. Ta-da! Now I have to just flatten out the cable because otherwise heat shrink won't do their job correctly. One heat shrink would be on this end to make my life a bit easier. Okay, just go there. Come on. Yep. Yeah. And then I'll just drop this puppy in. Ta-da! This is how it's gonna be. Then we're gonna plonk this puppy. Come on. Yep. Okay. Yo. Yes, this is done. Now, and yes, this is the side. So this is the box. It's supposed to be water resistant, and I have very weird doubt because the design wise it has two holes. It's supposed to have ears, basically plastic that is coming outside but not breaching the main chamber. Then I could have trusted it, but this direct hole is directly going there. It's like eh. So I would say it should survive mild what you call spray, but it will not be something that I will count on as like a proper watertight where I can trust in like heavy rain scenario. And be mindful, this threaded hole supposed to be used with a proper wire clamp. Now this 3 wires is not an ideal scenario. It's supposed to be used inside a conduit. You're supposed to use 3 core wire. 3 core wire meaning all of these wires will have, arre, what the hell, come on, come on, do not give trouble. Why you give me trouble? Why? This is proofing. Those wire grommets that's supposed to be for like proper water resistance, those are A, very expensive, and B, overkill for my requirement. I'm not going to mount this on a wall. It's mostly would be used indoor wise, so I do not have to worry too much about it. Yes. Okay, now we got it. We have to just make sure the cable is straight again, because once I start to shrink the heat shrink, I will not have any way of managing the slack, so to say. So cable has to be managed as well as possible. Come on, come on. Yeah, see, this kink would have caused a hell lot of a hassle. So why there is kink? Green wire, red wire, black wire. Yep. So if you want to have that grommet system, that would be generally used for this sort of 3-core wire. As you can see, like 3 wires are, then this sort of grommet makes more sense. So if you have 3-core wire, now you put it in, you plonk this puppy. That's how you do. Let's open this up. Thankfully, this is one thing that bothers me to no end. In India, we have like 2 screws, screw head on our electrical plugs. Basically, all the plugs, generally old ones only had flat head. The new ones, no matter how latest you buy, they have Phillips on the front, but on the inside they still have flat head. This is the first time I'm seeing any Indian electrical system where every basically screw is a Phillips head. So I'm very happy with that. And again, these are built far more robustly, because even though they are small, comparatively speaking, they're supposed to handle 16 amps. So you can see the slugs are like solid puppy. So I may do like this. Let's open it up. It does have a gasket, but like I'm not happy with the physical construction. Like it's better than nothing, I would give it that, but having 2 holes directly where you cannot seal it quite effectively, it's weird. So as you can see, it does have a gasket material, and here you can see you have a hole for grommet. Here you can use basically ferrules, or you can use car spade connector, but like I don't have that much of it. Actually, I have it. I don't have a crimper tool for it, so I'm gonna use it. And you can see like all of them are Phillips. That makes it easy. And this is what I was talking about. Like you can see some holes. It's like why do you have holes here? Like these holes make sense because these are outside of the frame. They're not in the chamber. The chamber has holes. So chamber ideally is only supposed to have one hole for the cable grommet, where you will have a grommet seal. Another would be the gasket seal. Nothing more. Having 2 extra holes makes it dubious at best. Now again, this is not designed to be used in a marine environment or like on a aircraft carrier, things of that nature. So it is what it is, and it's cheap stuff. So like I'm reasonably sure companies can make it, but there is a very good chance I will not be able to afford it if they made it like to spec, so to say. But like design wise, I do expect it. I do not expect quality. I do expect design. Design is easy to copy. So It's like, if you're copying the design, come on. Yep. Yes. So, okay. Yep. So we got this. Now we. Oh, this happened. This should not happen. Generally, your green wire should be the longest because no matter which plug you see, generally earthing is designed to be pulled out first. So green generally, depending, I'm coming from this side. Yeah, in this scenario, it may make sense as green is in the center rather than like. That's why I said like this design feels so weird. It's like it's supposed to be mounted like this from the electrical point. That's how it's supposed to be, but the ears are here. So yeah. Come on. Oh, okay. Let's move forward. Whatever happens, happens now. Okay, we have. Okay, now. Yes, this is done. Okay, I can go from here. Now, let's switch. Okay. Yep. Yes. Now I can. It has lot of travel, like unnecessarily large amount of travel is there. I have to keep doing this. Keep doing this. Now it has reached. Oh, and it does have ratings there. This is one mistake of this design, German plug. It's not polarity locked. For example, if you take any 3-pin plug, it's polarity locked. So because of this, it's locked. You cannot flip it. So if you follow the neutral live and your socket follows neutral live, you will get it. But on this design, as you can see, it's symmetrical. So it can rotate. But again, in industrial, you're supposed to use double throw switch, meaning neutral and live both should be disconnected because you do not know which one is connected. And that's why even like if you take angle grinders, things of this nature, this is made for India from Bosch. But again, as you can see, it has this weird plug. Can somebody tell me why the heck grinders do not have earthing? Like it does have metal. Why the heck it does not have earthing? But you can see like it can have double polarity anyway. Even drills have this. So that is why like I'm making this big beefy puppy. So let's black to neutral. Let's lock this puppy down. Lock it down. Then let's lock this puppy down. Lock it down. And then, okay, earthing, I have to open it up. Come on. Surprisingly long screw for earthing. Like ludicrously long. Unnecessarily long. Nope. Little bit. Yes. Or should I have it like all coming in the one direction? Yeah, that would be much better. This was stupid from my end trying to do this. Come on. Come on. Go in the hole, man. Ludicrously long screws, man. Yeah, the screw is the problem. It's ludicrously long. Yes, now I can lock it down. Okay. Now, one very important thing, I'm reasonably sure most of you know this, but if you don't, if you have any basically screw going into plastic and threads are very coarse, meaning you can easily see it, that simply means it's directly cutting threads into the plastic. So do not directly just go like this. So first you put it as straight as possible, then you reverse rotate it. And you see, took. That took simply means it caught into the tracks of the previous insertion. Benefit of that, it will use the same basically cuts, so to say. If you directly do it, it will keep making new cuts. Now problem is that it's plastic, it will chew up in like 2 or 3 times you doing this, and plastic will be completely chewed up. It will not have the holding torque, so it will feel very tight to do like this. I made that mistake, but like, but if you are inserting it, like put it straight as you can be, and then it's like rotate it reverse. Yep, come on. Yes, now you go inside. Again, it's not necessary to do, but if you wanna your screws to last at least 2 or 3 reinsertion, it's a good thing to do. Also depends on plastic, how strong it can be, like after how many chewing. Yes. Ta-da! Yes. So this is the industrial plug. Now I have a socket that can be used for basically my stuff, and I have this one that is ready for heavy amp use. And then I have a small one used for my oscilloscope. That was the main issue. The sole reason I'm doing this is because oscilloscope has an adapter like this which has earthing. I do not know how they connect earthing on negative, but apparently there is a large resistor there, but it is a desirable thing to connect earthing. And you can see, like, if you are inserting it, you cannot touch the contact, like there is no, and it's not connected yet. You have to go fully inside, then it connects. At that point, ta-da! So you can do this. I've turned you off, bro. Seriously. Yeah, the capacitor on the, it's an old school power brick, so capacitor takes a long time to discharge. Modern ones don't have that issue, but so this was my presentation on like industrial plugs, and they have its own uses. Hopefully you have learned something, find something interesting or useful in this. I'm gonna see you in next tutorial. Bye.